podcast. Today I'm in San Francisco. I'm not traveling. And Judith, where are you?
I'm in Barcelona,
You're in
Spain,
Barcelona.
like
Okay,
from my home.
excellent. At home. All right. And today we're going to talk about one of our favorite topic, which is how to use the LARVOL Clean platform to do network meta-analysis, NMA. LARVOL Clean, we like to think about it as a Google map of cancer data. Think about it at a place where you can find all of the collated and curated data about cancer clinical trials. Analytics on top, AI powered, curated by both humans and AI. Now, before we talk about NMA, network meta analysis, you notice my fancy glasses? It took me
Sure.
months to get it from Meta. So this is the new Meta Ray-Ban with display, a smart glass. It comes with what's called a neuroband. So as I move my finger, it reads the little muscles on my wrist, translated into selection. So I can do little movements like this. I can increase the sound like this. I can zoom like this, all kind of things. So in theory, it's going to be great. In practice, it's not ready for prime time, in my opinion. Don't buy one yet, is my. But for me, as I'm trying new technology, it's still interesting. Of course, one thing you can do, like in any smart light, you can say, "Hey Meta," and I've got a little screen that appears on my display. That's why I'm not looking at you. I'm looking at that little screen. "Hey Meta, what's the definition of a network meta-analysis in the biostatistical world, an NMA? Give me the definition."
Meta-analysis, NMA, is a statistical method that synthesizes evidence from multiple studies to compare multiple treatments or interventions, often using a network of randomized controlled trials.
I stop Meta for a second. I assume the sound is a little faint because it goes directly through my phone. It's actually very clear to me, but obviously less clear probably for the microphone. So let's move to our demonstration. Before you show, Judith, how to use the LARVOL Clean, in particular what we call the data studio, I want to
Mhm.
say that one element of LARVOL Clean is the data studio. The data studio is a place where you can take all of the already digitized data, all of the Kaplan-Meier curve that have been digitized, all of the hazard ratios, all of the other outcome data, with the largest outcome database in cancer from historical data. We also have the largest pseudo IPD, pseudo individual patient data, 3.5 million patients that have been pre-digitized. So what the data studio does is that it gives us access to all of that with a number of tools. One of them being NMA, but also you can do pooled analysis, pairwise analysis, overlay, building a forest plot, various type of biostatistical analysis in the box. So I'm going to pass the baton to you, but anything to add in general first, and then you can show a little demo for our audience.
Sure, indeed. I won't be wearing those smart glasses, like only regular glasses. Sorry. But yes, I'll be happy to be walking through our data studio and how like all the outcomes data that has been digitized can even like help you and ease the data analysis or any sort out any research question that would involve any clinical trial that has been published with digitized KM curves, pooled analysis, all the forest plots, meta-analysis, and even network meta-analysis. That would be the key element for today.
By the way,
So
after a while, it gives you a headache too. I'm not really helping Meta, but it's a little heavy, all right? So don't buy it yet.
okay, I'll take the advice.
They're not going to give me some free sample because don't buy it yet. It's not ready. It's not ready.
Maybe next time. Next
Despite
version would be for
despite
sure
Meta
better.
spending $75 billion on augmented reality and virtual reality, by the way.
So like indeed how we were saying, right now we are in LARVOL Clean, and please let us know like if you would be interested in like taking a closer look to our platform and what I'm going to be showing today. So basically under this data studio tab, that is the one that we're going to be focusing mostly today, we have 4 subtabs. The Kaplan-Meier plot tab, where we have all digitized KM curves that have been published. And basically, so we have digitized the KM curves, and you can do KM curve overlay, as Bruno was mentioning. I'm going to scan very quickly the first 3 tabs so that you can get a general idea. Then under forest plot, what we have is, again, the data that you would be having for clinical trials that you would be selecting. You can do very quickly forest plot using the, like building it based on the trial selection, again, that you might be interested in, okay? And then get pulled hazard ratio. And for non-time to event, you would be also even able to create a table with response rates based on a selected number of trials, okay? Following that same logic, what we have built under network meta-analysis is that you can select the trials of your interest. I'm going to go with a very small network meta-analysis for demonstration purposes on second-line plus EGFR mutated non-small cell lung cancer. And basically, in here, you would first need to select the trials. And from there, you select the actual endpoints. So basically, this NMA will be powered by the over 17,000 hazard ratios that we have populated in clean collected from published data. So we can select for Mariposa 2 OS data, for Paloma 3 OS data here published, and compel. So here the OS data. Okay. Once you have selected the hazard ratios that you want to use for your network meta-analysis, as basically what we're going to do, it's enabling the comparison of those 3 trials that have not been head-to-head comparisons, right? So derived from direct evidence, we're going to be extracting that indirect evidence that would be interesting for us. Okay. Once you have selected the trials and their hazard ratios, you can select the reference treatment. Okay. For that, yeah, I'm going to select this for now, as I will be doing some adjustments. So I'm going to run the network meta-analysis. And I lay in here. First, I have a data preview. I would be having the typical network plot. As right now, I do not have a connected network. I've just had 2 data points.
I've got a thought, Judith.
Yes.
Sorry to interrupt. If you were to select a larger number of trials, you most likely would have a connected
yes,
network,
definitely.
right? Yeah,
yes,
but
definitely.
In that tumor type that you selected, you don't have the choice. You don't have so many. Is that why you didn't select like 10 or 20?
The point is that there's a key element here, and it's what we have done in there is that there's lots of granularity in treatment definition. So what we can do is to consolidate the treatment names. And that's what you can do in here, that for instance, instead of laying it out as placebo, cisplatin, pemetrexed, we can directly call it as chemo. That way, we already have like an anchoring point. Similar way, the OSI plus chemo can be called out in here. Also simplifying the terminology that you would be then later on evaluating in the NMA. Okay, then let me, like with this simple change, I'm gonna add chemo as the reference. And now I've rerun the NMA and I get now the 2 of the trials that I've selected are connected. So that's one of the capabilities that we have added into our platform to, as you are saying, enhancing that connectivity. Otherwise, with the treatment granularity, you are not able to do that. Okay. On top of that, what we are currently working at LARVOL is to build an LLM-assisted network meta-analysis. What I mean by that? Basically, we are using the help of different, of LLM, we are actually doing trial selection and treatment consolidation before, like, given a key population. So let's say that we are interested in first-line metastatic non-small cell. So we do make a first qualification step where we consider like the recent trials, the trials that would fit into that key population, into that disease area. And then with the help of LLM, we're able to narrow it down, that list of trials, to those that would fit better into that key population. So the first line metastatic non-small cell lung cancer. So LLM would be helping us to defining the proper list of trials that would be eligible for that network meta-analysis. Not only that, but it would also help us in treatment consolidation, as I was saying. And for that purpose, I would like to share with you one of the first NMAs that we have run. Yes, I hope you can see it. Like in this case, you can see the selection of trials that has been used. It's much larger. And indeed, in this particular case, the sort of consolidation that was done was not only at drug level, but instead we went to the mechanism of action level. That way, even we are able to generate a larger network as the way of connections would be higher. What are the classes cheating?
I was taking a picture and then a video. Normally, there is yes, it's blinking in order
Yes,
for
it
people
is.
to know that I'm taking. So otherwise, I could take pictures without authorization. So I'm taking a video. Okay, I took a short video. Right.
Okay, that's nice.
Hey,
So
Mita,
basically, yeah.
don't you think that Judith is doing a terrific job in her presentation?
Judith is doing a great job in your presentation.
Thank you.
Right, thank you.
I'm back to liking Meta then. So basically, we are able to do the trial selection in a faster way. Like also, we have been reviewing the how accurate would be the LLM in assisting the trial selection and treatment optimization. And then, as you can see, even the network that would be generated, it's loading right now, would be, so you can see that there are some good connections there. Like we have the anchor, so the reference treatment, the chemo, where most of the trials would be lying there. We have then PD-1 inhibitors and so on. So this network kind of has a good shape. Then we can look at the forest plot. Most interesting usually, as usual, it's the regimen ranks. So how would the regimen we ranked if we were to consider efficacy, or probability of higher efficacy? And even from a statistical standpoint, you would be able to evaluate inconsistency and heterogeneity from the net meta summary. Indeed, right now we are focused on that level, so to confirm that LLM would be able to render an NMA that would be optimal, and that's where we are working mostly there right now.
So a few things. Number one, for the audience, if you would like to try our data studio, and in particular our NMA in a box functionality, please let us know. And we would love to set up a full demo with you, or organize for some type of pilot access to our platform. So that's number one. Number two, I want to elaborate on what Judith said, which is we are trying to bring NMA to the next level using AI. By having AI power the NMA and to allow for a faster and scaled up generation of NMA.
Mm-hmm.
In Clean, we even considering generating about 100 NMA for the 100 top special population in cancer. Okay, special population in cancer. And so we will have generated 100 or pretty soon NMA. Now, these NMAs, will they be Cochrane grade? You could say no, or you could say it depends of how the person who made the final selection of trials and consolidation, how well they did in their input into the model. But obviously, we're trying to move away from having a lot of human judgment involved, so that we can do it faster, better, and also with a standard approach, more AI-driven approach of selecting the trial and consolidating the regimen for these NMAs. So we're very excited about it. Any closing points on this approach? And again, congratulations, Judith. You're the one who built that with our colleague Darko and other partners. And I think it's a wonderful effort of an NMA in a box type of application.
indeed, even like with these studies to exclude, like you could even tie it down to the specific trials and like live, like that's important, right? Like the speed, that the accessibility to that data in a faster way. I think that's a great tool. Also with Samina, we're working with the LLM assisted. So I think that's going to be like very interesting upcoming NMAs that we will see soon.
I'm not a biostatistician, so I can say weird things. Imagine an NMA with every single cancer trial, all right? 100,000 trials in the NMA. And the NMA would use AI. I mean, it won't be a formal NMA at that point, but to try to derive statistical um, power value from every trial in every indication with every regimen, understanding on its own how much of a pattern it needs to or can extract in order to make indirect inferences, indirect conclusion about ranking treatments for a particular tumor type. So ultimately, that's our wild vision. Arguably, it wouldn't be called an NMA at that point. We need to find a
Exactly,
different
most likely.
term for it. But I'm thinking about, AlphaGo, right? AlphaGo could play a million game. Well, we could run a million NMA in theory and learn something from each of them that would make our AI smarter about making indirect inference about outcome and about the likelihood that a drug would have a better outcome for a particular population. So I'm very psyched, obviously, about what you're doing.
Yes, thank you, Bruno.
On that note, thank you, everybody. We hope to see you next week. And we will be at ASCO GU in San Francisco at the end of the month. And if you're there, we hope to see you there. Au revoir.